So now we are broadcasting, hopefully for real this time, and sharing the screen, hopefully for real this time. So the focus today is we've gone through these idea of interval estimates. But the problem is now reading the context of the problem and knowing which tool to use and getting some idea why it makes a difference, okay? So basically the thing you focus on, the two things you focus on when we get to figuring out which tool we use is, first of all, if this is a problem about proportions or about means. If it's about proportions, there's going to be a tool called proportion statistics in StatCrunch that we'll use. If it is a problem about means, then we've got to make a decision whether to use ZStat or TStat. Now, in the case of a problem about means, and we're making that decision about ZStat and TStat, the next question we look at is the standard deviation. Do we know the population standard deviation? Are we willing to assume that? Or are we just working with the sample standard deviation? If we're working with the sample standard deviation, we use the TStat setup. If we're working with the population standard deviation, we use the ZStat setup. So that's basically a preview of where we're going with this. Let's try this on a few problems and see how we goes. So we got 6 packages of Flintstones real fruit snacks. In that package, 5 of the pieces are Bam Bams. Total number of snack pieces was 68. What we want to know is the proportion of Bam Bam snack pieces in the population. Okay, so what we have X is our number of Bam Bam snack pieces. And in our sample, X is 5. In our sample, N equals 68. So in our sample, P, they use the expression P tick mark. I tend to use the expression P with a hat. This is the sample proportion. What fraction of our sample is Bam Bam? That is as simple as saying, well, let's divide 5 by 68. And if we want in kind of decimal form, we can go to Mr. Calculator and get 5 over 68 equals 0.0735. I'll call it 0.074. Okay, all round. So there is my P for the sample. Now, what we want to know with 96% confidence means when we're telling the computer to calculate this interval, we're saying use the recipe that works on 96% of samples of this size. Pick the Z or the T multiplier that works on 96% of samples of this size. So that's what we have. Now, first of all, you notice what we have is a sample proportion. It's a problem about proportions, not about means. Because it is about proportions, we use the command proportion statistics. In order to get a 96% confidence interval estimate of P. the proportion of Bam Bam snack pieces in all of the Flintstones chewables, not just this little bag. Okay? The command we use is proportion statistics. Why? Because this is a problem about a proportion. Okay? By the way, what proportion statistics is going to calculate is an interval that looks like so. P hat plus or minus. It's going to look up its magic number from the standard normal. You finally decided, instead of just snickering, to actually let me know that I wasn't broadcasting.
I need to know.
I'm glad you want to see it.
I raised my hand, but I got scared.
I'm sorry, guys. It's just so much, especially now. Again, today we've had problems with the, what's it called? AnyMeeting being used by another group. So I had to switch to this other program to record the class. And so I'm flummoxed about that too. It's just been, hopefully my sanity will return after Easter weekend. Sort of doubt it. May take a week after Easter weekend because I'll be going home Easter weekend and visiting Mama, and Lord knows that will make me crazy. Now. Okay, so way you get this, then multiply it by p hat times 1 minus p hat over n. Now, you don't have to actually do this because StatCrunch will do it for you. But that's what it's doing, is just like all our other confidence intervals we've seen so far, it's taking a point estimate and adding and subtracting a margin of error, which I believe she loves to call, your author calls, error bound. Or possibly maximum error of estimate. It's 3 different names for this same thing, this glob that we add and subtract to the point estimate in order to get our 2 ends of our confidence interval. But anyway, StatCrunch is going to do all the work for us. We just need to get into StatCrunch to do it. So we go here, get online. The StatCrunch. Log in. And go to Stat. And it's not calculators this time. If we were doing it by hand and using this formula, we'd have to put things in and then use the calculators, the normal calculator, to get this Z. But instead, going straight down to these 3 options: Z stats, T stats, proportion stats. And what we've decided is, since we are using a proportion, we are using the command proportion stats. Then we get to this choice of, is it 1 sample or 2 sample? It's going to be 1 sample because there's only 1 proportion we're about finding, as opposed to, say, the difference between 2 proportions. Third, if we had a list of yeses and nos over in column 1, we would be able to use raw data for this. But what we've got is a summary. How many yeses, how many responses? So our number of yeses, our number of successes in this case is 5. Our number of observations was, let's see what I recorded it as, 68. This is 0.96. And just to keep things easy right now, I'm saying let's use the standard walled confidence interval always in this class, okay? What there is sometimes in proportions, the reality is things are bunched up against the end sometimes. There's a low end of 0 and a high end of 100%, And sometimes things get bunched up, it gets the ends of that, and you get a better confidence interval by using another method by a guy named Agresti, I believe. Yeah, Agresti-Ekul. Okay, so that's usually how we do it, but we're using the method by Standard and Wald. Okay, that's not really their names. It's just a guy named Wald, and it's the standard method. Okay, so we're going to compute, and it's going to give us a lower limit and an upper limit to our confidence interval. Basically, we believe with 96% confidence that the true proportion of Bam Bam pieces is somewhere between 0.85% and 13.85%. 0.8085, is that right? Yes. 0.0085, so expressed as percentage, 0.85% and 0.3185. Okay, so that's our confidence interval. Let's check out and see how things go then for filling out the questions asked. First of all, define the random variables x and p in words. Well, we did that for here, for x. And ordinarily, when we're defining as opposed to saying what it's particularly equal to, I throw the word let. Let x equal the number of Bam Bam snack pieces. And let p hat or p tick mark that she likes to use be the proportion of Bam Bam in the sample. So just plain old P will be the proportion of Bam Bam in the population. P tick mark or P hat will be proportion of P in the sample. I can't remember right offhand why we don't use P bar here, but the symbol P bar gets used elsewhere. It gets used for something else. I don't know if we do it in this class. I think it is. I think it's used sometimes for what's called pooled variance, and we may briefly use it, but we won't really use the symbol P bar. Okay? So these are the two answers to that first question. Define X in words. Define P in words, or P tick mark in words. Next, which distribution would you use for the problem? What we're really after here is which command would you use? And I'd use the command proportion statistics because we've got a proportion. But in terms of distribution, what distribution proportion statistics uses is the standard normal. Normal means 0, standard deviation 1. So the answer to part B is, let's scroll down a little bit, normal 0, 1, because this is about proportions. And proportions, sample proportions, are normally distributed. So we use, and basically what we mean by using normal 0, 1 is we use it, or the computer uses it, to find that. And then it makes that calculation. It spits out at the end of proportion statistics. So to get this straight on the homework, in order to have it check off and be kind of comparable to what she does, when she asks what distribution we use, we're using the normal distribution. Even though sometimes what I will personally ask is which StatCrunch command we use. In that case, we say it's proportion statistics. Again, because it's about proportions. Okay? Part C, calculate P tick mark, the sample proportion. And we did that. So part C, we calculated P tick mark equals 0.074. I do believe that is what we got. Yeah, we calculated that just by dividing number of yeses by the number of successes. So there's C. Part D. Construct the 96% confidence interval. Okay? So we state the confidence interval. And I'm going to say whenever it says sketch the graph, just ignore that. Ignore the request to sketch the graph in these problems, in these confidence interval problems. But we will calculate the error bound, and it turns out it's easy to calculate it from this. Okay, so state the confidence interval. The confidence interval is this interval from the lower limit to the upper limit. So part D, part 1, we've got starting the lower limit, 0.0085. And on the upper end, 0.1385. There's my confidence interval. Or you might want to express it in this form, 0.0085 is less than mu, or P, excuse me, is less than, notice I didn't put tick mark, because we're not talking in the interval about the sample P, we're talking about the population parameter, what population proportion there is. So either one of these is correct for part 1. Part 2, we skip. Part 3, we go to finding the error bound. Now, what the error bound is about is finding this. And I think what she'd hoped you'd do is calculate just that piece and say, there it is. But the thing we're going to be able to realize about the error bound is we have this interval, and basically it's created by starting at the error bound, or starting at the point estimate, going up a certain amount, going back the error bound, up the error bound, back the error bound. So this interval is 2 error bounds long. If we take 0.1385 minus 0.0085 equals 0.1300, that is equal to 2 times the error bound, 2 times the margin of error, because it starts in the middle, goes up 1 margin of error, back 1 margin of error. That's how the confidence interval was made. So the confidence interval has got to be 2 error bounds, or 2 margins of error wide. So we divide by 2 and we get the error bound. 0.065 is the error bound. Make sense? Okay, in order to give you a little more work time, I'm not going to go through absolutely every possible problem here. But this is a good one. Yeah, 8.94.4 and 8.9.6 are good ones. So but I'm just going to start them. I'm not going to go through absolutely every deal, because then after it's which distribution to use and so on. Okay, So, but let's get these started then, talk about these. So problem 4, we've got a stack of IEEE Spectrum magazines. And in that stack of IEEE Spectrum magazines, they looked up announcements for 24 engineering conferences and randomly picked them out. The mean length of those conferences was 3.94 days with a standard deviation of 1.28 days. Assume the underlying population is normal. Now, let's back up here. First of all, assuming the underlying population is normal, what we'll do here works okay even if the population isn't normal. There are some things that work better, but this procedure we use for finding confidence interval is pretty robust to it not being normal, but they'll actually make this statement. Let's assume it's normal, okay? Now, let's see what we got. First of all, is this a problem about proportions or is it a problem about means? It's about a mean. So what that tells us is, first of all, that when we're going into StatCrunch, proportion stats is not going to be the command we use because it's about means. So it's going to be either T-stats or Z-stats because it's about means. Let's continue to analyze this. The second question we ask, which standard deviation do we have? Are we given the standard deviation of all engineering conferences or just the standard deviation of these 84 engineering conferences in our sample?
Just the 84.
It's just the 84. And they're not saying it's population mean or population standard deviation or sample standard deviation. But what they're saying is the mean length of the conferences in this sample was 3.94 with a standard deviation of 1.28. So that with, you kind of read to say, yeah, we're still talking about the sample. We're still talking about the sample. Therefore, what we know is S, not sigma. Question.
No,
Okay, so what we know is S, not sigma. If we are using S, so it's mean or proportion, first of all. This problem, number 6, is about means. So then the question we ask, once it's about means, we know that proportion statistics we then ask, do we know S or do we know sigma? And in this case, what we are stuck using is S. Now, when you're in that situation, what you use is T-statistics. That is, when you come up with that multiplier to create your margin of error or your error bound, when you're calculating that, you reference a T-distribution with n-1 degrees of freedom, or at least that's what the computer's going to do. That's what StatCrunch is going to do. You don't have it reference a standard normal with mean 0, standard deviation 1. If, on the other hand, it were sigma that we knew, if sigma were what we knew, then we would use Z-stat. Then we would tell the computer to reference the standard normal distribution when calculating the margin of error. Okay, so that's the situation here. And then they'll ask some questions, and just so you get used to them, I'll actually go through the start one. First question is, what do we use to deal with defining things in words means we make a couple of let statements. So in this problem, X is an individual. In this case, it's the length of a random conference. Oops. X is about a single individual. X bar is the mean length of a random sample of 84 conferences. Okay? So X bar is always the sample mean. Describe what the sample is, though. X is always an individual. Describe what individual what is varying from draw to draw. And finally, the distribution we use the command t-statistics. We use a t distribution with how many degrees of freedom?
-1.
What -1?
T minus, or N minus 1.
And what's n in this case?
The 84.
So we use 83 degrees of freedom. Okay. And then the rest is a matter of going into StatCrunch, just like we did with the previous problem, and calculating the interval itself, skipping the part about sketching the graph, calculating the error bound by calculating the length of the interval, and dividing that length in half. Okay? Finally, let's start 8.9.6 just to see what's going on with this. Suppose that an accounting firm does a study to determine the time needed to complete one person's tax forms. It randomly surveys 100 people. The sample mean is 23.6. There is a known standard deviation of 7.0 hours. And the population distribution is assumed to be normal. So let's break down. I say we do not use proportion statistics. Why not? First of all. So first thing, I'm looking at this and I'm seeing I don't need to use proportion stats, but the question is, what about that problem says I don't use proportion stats? It's about means. The sample mean is 26 hours. We're going to later construct the interval for the population mean time. So that's why we don't use proportion stats. So now we have that choice between t-stats and z-stats. And so what do we look for to make that choice?
Sigma.
Pardon me?
Sigma.
Sigma. Do we have sigma or S? Which is it that we have?
I think it's sigma.
There is a known standard deviation of 7.0 hours. So that's not referring to the sample anymore. That's not saying it surveys 100 people, the sample mean was this, the sample standard deviation was that, or they have 100 people with a mean of 26 and a standard deviation of, it's not referring to the sample anymore. Sometimes that's a little hard to read in these, but this is definitely talking about sigma, since it's the known population standard deviation. Okay? Now, if we are dealing with sigma, the known population standard deviation, in a problem about means, what is the command we're going to use over in StatCrunch? Z-stats is the one we're going to use. Z-stats with one sample. Because we know sigma, we know the population standard deviation instead of using the sample standard deviation. By the way, I think in one of your homework problems, they may give you both. And in a way, you have a choice. But I'd say if we feel good about knowing sigma, we use sigma instead of S. And if you use sigma instead of S, you refer to the Z-stats. Now, if it is referring to a command called Z-stats, what do you think is the distribution? So the command is called Z-stats. What is the distribution that a command called Z-stats probably references? Pardon me?
Sigma?
Sigma is the standard deviation, so it represents standard deviation sigma, but what distribution? What's the name of the distribution, the probability distribution that we use? We've talked about a binomial, we've talked about a t-distribution, we've talked about a standard normal distribution, we've talked about a continuous uniform distribution. Which one of those are we probably going to use here if we're using something called Z-stats? It's normal, standard normal. Z is this code for normal distribution, mean 0, standard deviation 1. So that's the distribution we're using. And everything else on this problem should be like what we've seen before. So you've got a few minutes to get started on this assignment. And so you have your computers out, and actually you can go into the homework, and it kind of focuses on odd problems, but that's how we attack the problems. And that's mainly how we attack this problem of which StatCrunch tool do we use. If it's about proportions, use proportion stats. If it's about means, you ask which standard deviation do I know. If I know the population standard deviation sigma, I use Z-stats. I use the normal distribution. If I have the sample standard deviation that I'm stuck using, then I use t-distribution with sample size -1 degrees of freedom. Okay. Well, there we are, and carry on.